Tengo que decirte algo. I got this feeling, you know? Let's go.
Creo que estoy in love. Cuando me miras así, yo no encuentro qué decir. Creo que estoy in love. No te pienso compartir, te quiero solo para mí. Yo ya me lo sé, esto así empieza. De pronto ya me tienes de cabeza. Creo que estoy in love. Creo que estoy in love. Cuando me miras así, yo no encuentro qué decir, solo puedo sonreír. Creo que estoy in love. Love. Again. Creo que estoy in love. Y no dejo de mirar fijamente el celular. Creo que estoy in love. Y es que no puedo esperar a que vuelvas a llamar. Te vas a quedar conmigo
I got this feeling, you know?
all night. Yo te quiero all night. Siempre despertar conmigo. Dímelo, 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 baby. Creo que estoy in love.
From the depths of our oceans to the heights of space, there are no limits to what we can accomplish when we push past our current boundaries. There is nothing more potent than the will to learn and to share what we know. The future is happening faster than you think. Curious about new tech trends? We're here to help you stay up to date with this fast-changing world. At each live talk, we will discuss different technologies and trends with global experts from countries around the world. Ask your own questions and learn how to get the answers you want to get on the forefront of technology with Tech Innovators. The electric car industry is booming rapidly. Hybrid cars and electric vehicles have created a global trend. However, the popularization of green cars is still an obstacle. Find out in Tech Innovators number 10, Shaping the Future with Electric and Hybrid Vehicle Technology. A special event with the participation of the world's leading experts. Dr. Sigmar Hasses, former Chief Information Officer, CIO at Mercedes-Benz, and founder and CEO of Hasses Digital Engineering Consulting. Mr. Nguyen Do Kin, Senior Vice President and Director of Global Automotive and Manufacturing at FPT Software. Mr. Frank Steinert, Branch Manager Vietnam and FPT Liaison Manager of NXP Semiconductors. What will you get when joining Tech Innovators number 10? Experts will help you understand a comprehensive review of hybrid and electric vehicles, the environmental and economic impact of electric and hybrid vehicle adoption, the technologies behind the vehicle. Register now to get inspired. From the depths of our oceans to the heights of space, there are no limits to what we can accomplish when we push past our current boundaries. There is nothing more potent than the will to learn and to share what we know. The future is happening faster than you think. Curious about new tech trends? We're here to help you stay up to date with this fast-changing world. At each live talk, we will discuss different technologies and trends with global experts from countries around the world. Ask your own questions and learn how to get the answers you want to get on the forefront of technology with Tech Innovators. The electric car industry is booming rapidly. Hybrid cars and electric vehicles have created a global trend. However, the popularization of green cars is still an obstacle. Find out in Tech Innovators number 10, Shaping the Future with Electric and Hybrid Vehicle Technology. A special event with the participation of the world's leading experts. Dr. Sigmar Hasses, former Chief Information Officer, CIO at Mercedes-Benz, and founder and CEO of Hasses Digital Engineering Consulting. Mr. Nguyen Do Kin, Senior Vice President and Director of Global Automotive and Manufacturing at FPT Software. Mr. Frank Steinert, Branch Manager Vietnam and FPT Liaison Manager of NXP Semiconductors. What will you get when joining Tech Innovators number 10? Experts will help you understand a comprehensive review of hybrid and electric vehicles, the environmental and economic impact of electric and hybrid vehicle adoption, the technologies behind the vehicle. Register now to get inspired. From the depths of our oceans to the heights of space, there are no limits to what we can accomplish when we push past our current boundaries. There is nothing more potent than the will to learn and to share what we know. The future is happening faster than you think. Curious about new tech trends? We're here to help you stay up to date with this fast-changing world. At each live talk, we will discuss different technologies and trends with global experts from countries around the world. Ask your own questions and learn how to get the answers you want to get on the forefront of technology with
Welcome everyone to join the 10th issue of Tech Innovators, a series of events designed for developers and people working in tech. My name is Diệp Anh and I'm going to be your MC. I'm so glad to be here today. As you may know, at each live talk of Tech Innovators, we will discuss different technologies and trends. And today we have the honor of having our top experts in automotive field from all over the world sharing their vast experience and great insight about the topic of shaping the future with electric and hybrid vehicle technology. And now, let's introduce Mr. Kính Nguyễn, who will be the moderator of the webinar. Mr. Kính, please unmute your microphone and moderate the discussion.
Thank you, Diệp Anh. My name is Kính Nguyễn. I'm working at FPT Software technology. I'm from FPT Corporation. I've been with this company for more than 13 years. And with me today, we have expert from. I think it is better to have introduction from each panelist. Frank, do you want to start yourself?
Yes, of course, I can. Hello, everyone. My name is Frank Steinert. To introduce myself, my professional career is based on software engineering, even if I graduated in electrical engineering. In 2008, I have joined Freescale. I was hired because of my automotive background. And at that time, Freescale began to own automotive software. In 2016, Freescale and NXP have merged. And at that point, I became an employee of NXP. Now I am in my second term in Vietnam. This is my 4th year here. And I'm filling 2 roles. The first one is I'm acting as NXP's liaison manager at FPT. We have here contracted about 500 software engineers. And the automotive segment will pass the 400 contractors threshold in 2023. That's at least the plan. And my second role is that I'm managing NXP Vietnam, which we have established this year. And currently we have 6 employees here and we are hiring. No, thank you.
Thank you. Siggy, do you want to introduce yourself?
Yeah, hi audience from Asia, from Europe, from US. It's a pleasure to join. So my name is Siggy Hases. Background, I started as a mechanical engineering, or first I did vocational training as a mechanic, studied mechanical engineering and computer science, ended up with a PhD, and then started at Mercedes-Benz. I spent 27 years at Mercedes. Every 2 to 3 years, I moved to the next location, next business function, next responsibility. So therefore, a big background in engineering, in R&D, in research, in production. To sum it up, my second last position was in Asia. 2010, I started in Singapore. Then I moved to Beijing, China, responsible for all the 20 markets in Asia. And my last position at Mercedes as CIO R&D Mercedes, with a team of around 1,000 people around the globe, pushing the enterprise IT, enterprise software, but product and vehicle software as well. So in that role, we developed a digital twin, or a digital prototype for digital validation, VR, AR, all this stuff, but the bill of materials, vehicle software, software development, Mercedes-Benz operating system, and stuff like that. We will explain today. After 27 years, my boss said, "Hey, Siggy, what's next now?" And he said, "You could do this and that." I said, "Hey, boss, I have even a better idea. Let me jump out. I will start my own business." At the beginning, he said, "Oh, no, Siggy, that's not a good idea." At the end, he said, "Okay, I will support you." And this I have done. Last year, I stepped out, started my new business now as an advisor. So I'm advising digital companies like FPT, and happy to be now advisor to the board and supporting the FPT team. Thank you so much, and looking forward to a fruitful discussion with you guys.
Thank you, Siggy. Dr. Dung, do you want to introduce yourself?
Yes, thank you, King, and hello, everyone. My name is Ding Tien Dung. My background was aerospace, and I started my first job in aerospace industry, and now I'm in automotive industry. So my last position, my last 4 years of working was in VinFast, and I am the former CAE director of VinFast. You know, CAE stands for Computer Aided Engineering, and it could be understand that calculation, simulation, and analysis. So I'm very happy today to be here and to share my perspective with you. And thank you all for joining today. Thank you.
Thank you. Thank you. Okay. So we did share introduction, and I would like to share a little bit about FPT, because this event is held by FPT. So I would like audience to get a quick quick understanding about FPT. Organizer, can you share your screen so that I can explain it easier? All right. So we are FPT Corporation. We have multiple businesses, from software, technology, to telecom, to education. So in Vietnam, we have FPT Shop as a retailer. We have FPT University and high school and everything related to education. Today, we come from FPT Software, the global company to provide technology software services to global enterprises. We have 25,500 people now, operating in 26 countries in the world, 59 offices. And our strength is to combine the local presence in customer side in US, in Japan, in Germany, with the technology resources, engineers from Vietnam, mainly from Vietnam, but we also have a development center in Philippines, in India. So we call it best shore. Best shore means the combination of on-site, nearshore, and offshore. So that is about FPT. And automotive, obviously, is one of the biggest segment in our customer base, and that's why we are so excited to share with you guys today about the EV, the automotive, new trends. Organizer, can you go to the next slide? I think some audience already heard about the ACs, or somebody call it case. Never mind. It stands for the biggest trend, mega trends in this automotive industry. So the A stands for autonomous driving. So you can see Tesla, GM, even VinFast, or many OEM, car OEM now striving to reach autonomous driving functionality from level 2, level 3, and in the I think far future level 5. So autonomous driving is obviously is a big trend in this industry. The second C stands for connectivity. So the car now will be a smartphone with the 4-wheel. And it means that the car will have the connectivity to the internet. It will have the functionality to be updated by wireless technology over there, and it will be more like a smartphone we use every day. The third trend for this industry is electrification. So EV is or EV. So from nearly 100 years, so we use the internal combustion engine, and now the global trend is to move from IC combustion engine to the electric car. Yeah, and the last S stands for shared mobility. So the way of using, the way of owning the car will change. So nowadays everyone is trying to have their own car, so they buy a car. But in the future, they may not need to own a car. The car will become a mobility. Mobility as a service. So they can lease the car, they can use the car, they can rent the car for per hour or per day or per month or per year. But they don't need to use to own the car. So it means shared mobility. Okay, this is a big trend. I would. Can you go next?
May I ask? May I add some aspects to this slide?
Recording in progress.
Yeah.
So I mean, these 4 pillars at Mercedes we called CASE: connected, autonomous, shared, and electric. So this last topic, this sharing, to be honest, I do not see the big potential anymore. So at the end, the customer decides, is that really helpful and creating value? I've seen many initiatives and companies stopping their business because less need for sharing. So in the beginning, Mercedes, Volkswagen, Audi, even Mercedes and BMW created a joint venture just pushing this, but they stopped because sharing, the one out of the four big things, is not really needed by the customers. Connected, autonomous, and electric, definitely, that's the number three. Sharing, I do not see anymore this huge need and requirements from the customer base.
Great, thank you for the perspective. Okay. I think today's topic is about the electric car and hybrid. So can you, organizer, can you go next? I would like Zoom to share your view about the EV.
Yes, thinking. And before I start this one, just to continue to share my thought about the S, right, in the ACE trending. Maybe S will not be the share anymore, but it will become like simple or simplicity, right? So we see the design of the vehicle now become more and more simple. So maybe like S can become like simple or simplicity in the design. Okay, just want to share this. Yeah, before I start this section. So yes, so I would like to share like some idea about the ICE to EV transition. So I stand for internal combustion engine. It means that gasoline vehicle, it's traditional vehicle, right, that we are driving right now. And EV stands for electric vehicle. So if you have a look at the chart on the right hand side, you can see, right, the global EV sale volume for the last 10 years. From 2011 to 2021, right? So from 2011 there was only 55,000 EV was sale, but after 10 years is raised to about 6.8 million electric vehicle. So it's almost more than 100 times, right? So we see a huge number. So the transition already happened, and also happening right now. Besides, we see like a more and more regulation from government about the emission reduction, and those regulation helping to accelerate the I to BEV transition. You know, in Europe, require zero emission in 2035, and Vietnam also just not a long time ago, right, commit almost a similar situation in 2050. So the regulation have to push the transition quicker and quicker. And now you can see a lot of electric vehicle on the road. For sure, in the US you can see Tesla or Ford or GM. I think you see Audi, Mercedes in Europe, and in Vietnam, right? Of course, VinFast. Well, we already have VF E34 on the road, and very soon, right, VF8 and VF9. So it means that I cannot like show all the vehicle model here, but there are so many electric vehicle already on the road, and the transition again already happened, and will happen also very fast, quicker and quicker. Yep. So please.
Thank you. So I believe that the EV need like the traditional car, it still need engineer or technology in hardware, mechanical, electrical, and software. So because you are expert in hardware in CAE, can you share what should be the difference between the traditional car and EV cars for the EV for the in terms of hardware? Yeah. Okay.
Yeah, sure. I can do that and share my my knowledge with the audience here. So almost my career in automotive industry, I was working in CAE, right, in simulation, let's say, in simple. So and in development electric vehicle. So hardware that King mentioned, you can understand that the structure of the vehicle, right? And software is like the software, and King can share more detail about that. So about the hardware, I just list here four main direction that I'm seeing is happening right now as technology for electric vehicle development. The first one, as you can see here, is efficiency focused design. So what does it mean? It means that like the design of electric vehicle now focusing more and more to the efficiency. For example, right, like weighting, more energy density for battery, or more efficient power chain and mechanical system. So all of efficiency will help to reduce the energy consumption of electric vehicle. Therefore, extend the range of electric vehicle, right, which are very important for electric vehicle to compete with traditional ICE vehicle. Second one, like is HV system safety enhancement. So the main difference from electric vehicle, right, from the ICE vehicle is HV system. HV stands for high voltage system. For example, the high voltage battery. So this is very important to protect HV system to ensure the safety of electric vehicle, right? And we see more and more concept in structure, also in functional, to protect the HV system. The third one here is a new manufacturing technology. One example is the Giga Press from Tesla. They just published like some time ago. It means that, for example, instead of making the underbody from a lot of parts, here about 70 parts, they just make underbody as a single one piece by Giga pressing. So it can bring the benefits of timing, of cost for sure, and also for reduce the complexity of maintenance during the whole life of the vehicle. And the fourth one is the CAE. I want to emphasize a little bit on this one, or we call like a virtual development. You can see the animation, right? It's like the simulation of a vehicle hit the rigid barrier. So instead of making a prototype and make a physical test, which cost time and money, so now we can use a computing tool, right? It's CAE tool to simulate the crash. And you can see the weak point in the design and improve it early in the development phase of the vehicle. And it can help to reduce lots of money, right? Instead of making the physical testing. And also another trending for now is the virtual sign-off. It means that for some kind of simulation, when the result of simulation very close to the result of the test. So we can use the result from simulation to replace the physical test and to sign off the design. Okay, and relating to the simulation, I think very dominant trending for now is a digital twin. Very more related to the software, and I believe Mr. Sigi here is a big expert on that field. So Sigi, maybe you can share more with the audience about the digital twin.
I mean, the digital twin will be the first step for digital transformation. I can still remember 6 years back when I had a discussion with Ola Kalenius, the big boss of Mercedes, because he was the godfather of the digital twin at Mercedes, and he said, Sigi, it's important to come up with clear additional value streams. Why we should build a digital twin? And I said, okay, it's always, I mean, this magic triangle in cost, in time, and in quality. And I said, with the digital twin, we want to reduce dramatically by 30% the hardware prototype cost. Still, the OEMs are using too many hardware prototypes. We could do much more in the digital validation. So we said by the digital twin, reduction by 30%. Still, the OEMs are using too long for the product creation process, coming from 6 years, 5 years, 4 years. The clear target is 3 years from start of the requirement process to start of production. And I told him, okay, with the digital twin, we could accelerate by 12 months, 12. And also we could improve the quality, the maturity of the whole product. So therefore, this is the input to CAE. I call CAE the digital prototype with all these segments Sung has explained, and battery now is a new domain. And definitely it's also the input for visualization. It's the metaverse, it's VR, AR, and stuff like that. So having access to the data is important, using APIs to have access to all of the relevant data, all of the relevant systems, applications with APIs, to use the relevant data to uplift this in a data layer and to provide this to role-specific cockpits to dramatically make the business much more efficient for all people end to end. So therefore, it's a combination of CAE, digital prototype, and the digital twin, having access to all of the data from engineering to production to sales to after sales to life cycle.
But we must also consider that there will be not that single digital twin that will always be tailored for the specific case we want to analyze or to model. If you look, for instance, on the screen, you see on the bottom right, that's also a digital twin of the mechanical structure of a car. We may have several digital twins for certain aspects, for the autonomous drive part, for instance, or for the vehicle infotainment. And it's impossible to model the entire car with all the aspects. We will have to abstract away what we don't need for the specific case we want to analyze. Therefore, there will be plenty of digital twins for each of the models for the entire lifetime.
Fully agree, Frank. When I started building the digital twin, I just used the singular, one digital twin 7 years ago. But absolutely, I fully agree. Now we have multiple digital twins for digital purposes, for different use cases, definitely. But the philosophy is always the same, to have a digital representation of the car, the shape, the body, the software, the behavior, and also the whole functionality, but from different angles. So therefore, definitely, today I would also use the plural of digital twins. So we have many, many digital twins, like you said, Frank. Fully agree.
Thank you. Thank you, Frank. And
one point.
Yes. I think, yeah, we just share about the hardware and digital twin. In addition to that, I think software is become more and more complex with the new architecture to adapt with the EV and the user experience trending. Can you go back to the previous slide? I think, yeah, Sigi or Frank, you can share your thoughts about.
Yeah, I mean, we have seen
software and EV.
We have seen such kind of newspaper articles during the last 1, 2, 3 years because we already mentioned connected is one of the big mega trends. That means not that much hardware oriented anymore. Still, hardware is important. Still, it must be robust, it must be luxury, it must be agile, definitely. But the last 20, 30 years, the product development has been dominated by hardware, and the software was just, I mean, a consequence, was not really software dominated. This will now change from, let's say, a 90-10 ratio to a whatever, to a 50-50. So that means we start now much earlier with the software. Everybody wants to become a software-defined company, a software-related company, to start first with software. Software will definitely play a much more important role. That means with the vehicle operating system, with autonomous, highly automated driving, all this kind of software will be more and more important, will be a differentiating factor. And therefore, all the companies, not just automotive, but also other industries, they just think in which area we want to make our money in the near future. And definitely, software data will become more and more important. But you can see, I mean, all this kind of newspaper articles, all of them want to hire 2,000, 5,000, 10,000 new software engineers. But you won't find these engineers, these additional engineers in Europe, in the US, in Asia. So therefore, still we need the kind of collaboration. But the good thing is, already Kin mentioned this best offer, or how could we build hybrid teams, mixed teams from offshoring, from onshoring and on-site will help us to bridge this critical situation. And perhaps to explain how the whole software development process will change, This will show in the next slide. So if we just move to the next slide, this will change the big difference of the software development process in the automotive. So please help me to switch to the next slide. In the past, when a OEM built a luxury passenger car, but same for trucks and vans as well. But let's start with a luxury car, like a Mercedes S-Class or a BMW or Audi, or I mean, even US and Asian cars. The soul, the behavior of a car has been represented by ECUs. The electronic computer unit. So this ECUs in the past has been defined by, let's say, the OEM, but then shifted over, handed over to ECU builders, the ECU companies like Bosch, Conti, the big ones, the smaller ones, at the end to build 150 ECU boxes. And these ECU boxes, spaghetti coded, I would call them, of hardware and software. So 150 small computers with software and hardware coded, really hybrid ones, not separated, but just 150 pieces, blocks. At the end, from an OEM perspective, after handing over 150 boxes, ECUs, from the ECU vendor to the OEM had to integrate these 150 boxes. But less opportunity to do flashing, to do a software update, because 150 boxes and no room, no space for optimizing or flashing. The next generation is to separate hardware and software. That means not 150 small computer boxes anymore, but just one main computer station. And with this main computing, using a reference architecture on top of that, we can create in 150 domains or zones this software. And ideally, the OEMs want to build by their own team this software, but they can't find this thousands of new software developers. So therefore, still, they need partners for AutoSAR and other, let's say, software ECU-related software development to create this software. The good thing is with this new package, with this new concept of the architecture and the separation of hardware and software and this agile reference architecture, you can still do software updates over the air. And this comes to the target like Ola Kalenius mentioned some years ago. Until 2025, he want to earn 1 billion euros with software and data products. And this software operating system helps him to do it, to be ready, flashing over the air. But at the end, we have to create software, additional software packages a user, a customer wants to have and willing to buy. And this is the new way how to build the software in the car using this reference architecture, first organized in domains, main domains, smaller domains, and in the next step to organize this in car zones. Kim, back to you.
Okay, thank you, Sigi, for sharing about the software. So one thing I would like to emphasize here: not only software, it needs computer chip, need a semiconductor. Frank, do you want to share a personal opinion about? Do you want to add something on this?
Yeah, of course I can share a bit about my thoughts. When I joined Freescale in 2008, we hadn't had any automotive software in our automotive department. When we thought about software, it was about compilers. Our customer need to compile code for our controllers. or tools to configure the registers of the controllers. But since then, we are forced a lot by our customers to provide software to enable our customers to develop application software they need to run in the car on top of the hardware. They don't want to care much about the registers. They want to use the functionality, and ideally they get a software interface they easily can integrate into their middleware, application software, whatever, to integrate much easier than it has been in the past, the ability for them. And now we are forced to invest a lot in software development. Even we are still looking for hardware engineers, but we are also looking for many, many software engineers. We will still remain a hardware or a silicon vendor, but we will have to provide software to our customers to enable them to use our hardware. And if you look on the architecture of those controllers and microcontrollers we provide, they become also very sophisticated systems. They have that many different functionalities, that many cores, different cores in them, that we must provide additional software to the customers to leverage all that functionality in the chips. If it would not do, they could not really utilize the stuff we have built in our controllers and microprocessors. And therefore, that will grow further.
Thank you, Frank, for sharing from the semiconductor.
Maybe one additional point: you can see the importance of software if you look on the history of our offshore development center at FPT. In 2008, we began with some translation for controller handbooks from English to Japanese, with, I remember, 10 people. And now we have 500 working for us, developing, testing software and ensuring the quality of the software. And that is really, and that's rather exponentially growing. And that will really speed up. You can see how the importance of software is really growing over time. And I don't know where the end will be.
Thank you, Frank. Yeah, interesting for the software company like FPT. Okay, so audience, organizers, could you go to the next slide? Okay, so discussion. Thank you all the panelists for the sharing and the insight. I have one question to audience, to panelists here. So we see that today the Tesla is more, I mean, in terms of market cap, they are bigger than the Toyota and plus some OEM. So is it kind of difficulty for traditional OEM to compete, to move quickly compared to the newcomers like Tesla, Lucid, Xpeng, or Neo? So my question is, why is it so challenging for those traditional automakers to break into the vehicle business, considering the domain expertise, resources, and the ecosystem? Feel free to take the question. Dung, Sigi, Frank.
I mean, let me start from an OEM's perspective. You run this processes, methods, tools, your workforce, your whole organization now for 150 years. So you have experience of 150 years of combustion engines, of engineers, of processes, methods, tools, supply chains, vendors, organization, skills, universities train the people. Everything is pretty much optimized for powertrains, for combustion engines. And therefore, it takes a while to like a tanker. I mean, to change now the course, and definitely what Tesla started to do is the clear North Star also for the other OEMs, but it takes a while because imagine you have hundreds, thousands of mechanical engineering engineers, PhD guys, processes, methods, optimization stuff. Even the whole supply chain is focused on this. And this you have to change as fast as possible, but in a robust way. And if you have now a look on the current development processes of the OEMs, more or less all of them are moving towards a BEV fleet. So, for example, Mercedes now announced the next generation E-Class will be the last one with a combustion engine, and will be introduced next year. This will be the last one with a combustion engine. Already, like called EQ, all these cars now on the road for BEV, for battery electric. So therefore, this is just Mercedes, but the same you can see on Volkswagen, Audi, Porsche, even the sports cars, they come up with battery architecture. Definitely, there is not the sound anymore of a V6 or a V8 engine. Perhaps you need artificial sound, but definitely what I recognize now is already the new tour, the new North Star is clear to come up with only battery electric cars, or in the next generation also fuel cell. But the combustion engine area is gone, but it takes a while, and 150 years of experience means now you have to rebuild this experience for battery systems as well, because you have your battery, your powertrain plants, and this you have to migrate to morph to battery and to EV plants. So this takes a while. But anyway, I can see already the big change of all of the big OEMs.
Yes, and just would like to ask one more point to see that, yeah, we understand that with the traditional OEM, they have a long story, 150 years, and they are big. So when they're big, they have a big inertia. So like I share my point as a startup company, right? So with startup company, they're smaller and we move faster, and we can see in the approach. So traditional OEM and startup approach to the electric vehicle by different way, as you mentioned, right? Traditional OEM such as Mercedes or Audi, they start the EV development from the ICE platform. So they start to convert, right, one gasoline platform to one EV vehicle. So we see, especially for Mercedes, right, they have like EQS or EQ, or right, on the vehicle converted from an ICE platform. So it's not easy for them to change like immediately to develop a purely electric platform. But the different story for startup companies such as Tesla or Lucid or other company. So they start directly to develop the pure electric platform. They never start with a transition, or let's say a transformation from the baseline from the ICE platform. So the approach is so different from traditional OEM and also from startup.
Okay, interesting. One thing, not only electric vehicle, but also hybrid. You know, the gas price is increasing. It's like a very fluctuation, difficult situation now all over the world, not only Vietnam. So people start to, even some of my friends in Vietnam start to think about buying a hybrid car, because it's already a mature, proven technology and already good price. So can you share your idea about hybrid and then why it matter? Why is it any different, or any direction why people need hybrid instead of EV?
So yes, so from my personal point of view, right? Let's say the hybrid is a kind of an intermediate step of transition from ICE to fully electric vehicle. So it's some way like when you need to make jumps, it's not easy for everybody. So somebody just make a smaller step. So hybrid is a good step, and it happens also um, to make the customer right more have more experience with electric powertrain system, for example, and they have also they will know like quickly electric motor because when it run right, you don't hear almost anything. It's very quiet, for example, at some speed, and also for customer who drive a hybrid vehicle, they also know about some technology such as regenerative braking. It's very popular for electric vehicle, right? It means that you can recover the lost energy during braking to charging energy to the battery and use back for electric motor. So the kind of technology, not fully electric vehicle, but it helps customer to not to need to make a huge jump to the full electric vehicle, but step by step. But from my personal perspective, the destination and the target will be the full electric vehicle. Because as we talked about at the beginning of the webinar, right, a lot of regulation now from government are accelerating this transition by emission reduction regulation.
So Sung, I agree. I do see the hybrid ones as just a bridging technology, not a final technology as well. Just starting with the European Parliament, which decided to ban, beginning of 2035, all kind of combustion engines for passenger cars. That means a hybrid with a combination of a BEV, a battery electric car, and a combustion engine will be banned as well. So 90% of all OEMs, they recognize hybrids as just a bridging technology, not let's say a North Star, a final target technology. Still, there are some others in Asia will focus still on hybrids. We will see. We will see what the customers are requesting and what the local laws are, let's say, asking for, and a clear guidance from them. But definitely, I do see, let's say, the battery-driven first, and then perhaps the fuel cell. But this comes not in this next generation, but perhaps in the next generation. But I guess this we will discuss just in a minute, right?
Yeah, I think it's an interesting idea and perspective, because I've been working with Japanese OEM for years, and Toyota as an example. So they have everything. Of course, they have IC, they have internal combustion engine, they have hybrid, they are releasing aggressively the EV, BEV, but in parallel they still have hydrogen. So the philosophy is they want the customer to have multiple choices. So they don't think that EV is a final destination. So this is interesting in terms of countries, political, political issue, I believe. Yeah. So you just mentioned about fuel cell. So what should be the potential of fuel cell in the near future?
So discussing fuel cell, I would currently distinguish between use cases in trucks and in passenger cars. I do see already the potential for fuel cells in a truck, and I'm expecting the potential for fuel cells for passenger cars, not in this generation, but in the next generation. Why? The fuel cell That's my private opinion. They are still facing challenges. So fuel cell, the challenges are, let's say, the missing charging ecosystem. It's the high production cost. It's the robust behavior in, let's call it, the physical border zones. Like if it's extreme cold, if it's extreme humid or it's extreme hot, or if you have a vehicle crash at high speed. These are currently still, let's say, the challenges, but this definitely we will solve all these issues, all these challenges. In a truck, you can reduce this risk because if you have a fleet, this easily or a bus organization, then you could easily find solutions for the hydrogen charging ecosystem. The production cost not that important, and also, I mean, these high-speed crashes could be avoided. So you have more space to build a safety frame of the around the fuel cell system. So again, I do see already, and you can see many of truck OEMs already building this fuel cell cars and trucks and buses, already some on the streets. For, let's say, for the fuel cell cars, yes, you can also see some, but with the fuel cell car currently, you can't earn money. You will burn money right now because of the production cost. But I do see in the next generation the high potential of fuel cell cars as well.
Okay, good. Oh, I see a lot of like nearly 100 questions already from the audience. Somebody report to me that already 5,000 people is watching us. Oh, we need to answer some question, important question. Yeah, but before doing the Q&A, one thing I would like to ask, because we have chip maker, we have OEM, we have software people here, and we are talking about EV. One thing, could you share your idea and thought about what should be the difference between the software and connectivity for traditional car and for the EV or hybrid car? Frank, can you take this?
I don't have the absolute truth. I can tell a bit about my own opinion on that. I believe that this change from combustion engines to electrical vehicle causes for sure triggers the motivation of software development. In the past, it was mainly driven by compliance to regulations. That the regulation defined, at least in Europe and US, that the fleet of the car OEMs must emit less gas, or I don't know what's the term in English, that they become much cleaner than they have been in the past year by year. And that was mainly driving the innovation in controlling the engine and the motor control. But due to the change or the disruption in the market that becomes much more fragmented by new OEMs, which entering the market, competing with the established vendors, they are forced to improve their ability to change the car during their lifetime. In the past, it was they produced the car, configured it, shipped it, and then for 15 years it was almost the same. But that will not any longer work if the market becomes much more competitive than it has been in the past. New entered OEMs appear with much better customer-oriented solution. They think about the continuous improvement of the user experience, or they think about improvements of the energy efficiency or the efficiency in recharging the car. And that will drive software development much more than it has been in the past. That is all that what the customer really experiences. The motor control software was under the hood. The customer did not get it. He could enjoy the BMW with this dynamics and things like that. And that was sure the fruit of a perfect engine control combined with a perfect control of the wheels and the braking and torque distribution. But that is much easier in the future because we have those electrical engines or motors which we can much easier control. For sure, here's also potential to become more customer oriented. You can be smoother, more sportive, whatever, but it's less complicated. In the past, much more user experience aspects are coming from how the car behaves or appears to the customer and how it can be changed over time. And that will open also there's a need for the OEMs to gain business and revenue during the entire lifetime by selling new features, upgrading the car, have the ability maybe also to replace hardware easily. That means that the architecture of the car must also support those hardware exchange over time. And for sure, the continuous update of software. And if the car becomes more connected, then for sure it becomes also more exposed to threats. And that also causes that the OEMs must think about the continuous healing of threats, that they become able to fix any issue that appears in terms of the protection or the security of the car, that it cannot be hacked, misused, whatever. And that are from my perspective, the main drivers for the software. And that for sure challenges us as well, that we also must provide the respective basics for that with our chips, with the software that sits on those chips, and also the additional software the customers are asking from us.
Thank you. How about the material in terms of hardware or material or the aerodynamic for the vehicle? Is it any challenge or different compared to the traditional car? Dr. Dung, do you have any thought about that?
You're thinking so it's like, let's say it's dominant different, because for electric vehicle, right, we always try to design the vehicle with more efficiency. It means that we need to reduce the drag, the air drag, right? It means that we need to improve the aerodynamic shape of the vehicle. We also need to reduce the weight of the vehicle, right? So all of those we have to reduce the energy consumption and extend the range for electric vehicle. So these are also a big difference from the electric vehicle from the combustion engine vehicle.
Okay. Thank you. I believe we already shared our thought and about the trend, about the regulation, about a lot of things. Organizer, should we jump to the Q&A session? So for that, for our audience to ask the speaker here lively. I see a lot of questions come to go back to the question. I see a lot of questions jump to the box. Should we have please forgive me, a lot of questions, so let me take some. I have a question from Mr. Tuk Nguyen, SAP, America. He is asking about can you allow Mr. Tuk to join this session? Or I will ask the question instead of, on behalf of Mr. Tucker. Okay, to save the time, let me ask a question. So Tucker asked that, what do you think about the role of supply chain in new vehicle development? Oh, interesting. Panelists, are there anyone to take this question?
Allow me to share my idea first. For sure, we will see a big change, right, or a new opportunity for the supplier chain, because for electric vehicle, right, we have more and more feature in comparison with combustion engine vehicle, where, for example, right, infotainment, it's like we heard about like smartphone on wheel. So there will be more and more supplier can provide infotainment system for electric vehicle in both hardware and software. So it's a new, almost new supplier chain, or let's say the new opportunities for supplier. Even for traditional supplier, they also need to train, right? For example, the tire. Maybe you heard about like even the tire supplier, they need to develop the new tire for electric vehicle. I mean that with better rolling, let's say resistant coefficient. You mean that with less friction, so will allow the vehicle to travel more in distance. So yeah, my perspective with that, is like very important role of the new supply chain in the new vehicle development.
What comes into my mind, a lot of aspects. I mean, a very complex question, supply chain. All of us, we are currently recognizing, let's say, the sensitivity of supply chains, right? So definitely, but this is not only focused on battery electric, but in general, we have to robusten the supply chains, to manage the supply chains. But this is in general. Topic-wise, battery elements will become more and more important, and the OEMs have to decide to which level they want to create value by themselves, to build own plants, and how to build, let's say, the supply chain. Who are, let's say, number one set? It's the new way of hardware and software. Software not just let's say linked to the hardware, but separated and with AutoSAR adapted and new formats to share, to provide it to the OEMs. I'm expecting new players in the supply chain, not just the old ones, but new ones, focusing on the strength, on the functionality, on the integration level, on, let's say, the range and all these activities. So I would say the run started, and I'm expecting there a lot of new players and let's say a new way to integration. So I'm expecting also not just the big ones, also smaller ones, fast ones. Speed is really important. Speed. I'm always asking for to come up quickly with the appropriate technology and adapt with the OEMs and first-tier suppliers. So therefore, a lot of change I'm expecting there.
So we are facing the chip shortage issue all over the world. So from that chip maker perspective, Frank, could you share your personal idea, opinion about the supply chain for the EV industry?
I don't know. For sure, it has impact. And, I don't know, but maybe in a more generic way, in the future, for sure, chips will matter, software will matter, and many parts must be assembled to build a car. And therefore, we will always have issues if the global collaboration is somehow disrupted or broken. And I believe it's impossible for OEMs to build everything locally. We need international collaboration. And to share the access on resources, development resources, natural resources, the energy production for the electric car, for instance. It's impossible to produce that, I don't know, in a country which has not much natural energy and not enough sun and wind. They have to import energy. We need an energy supply for that. We need the infrastructure to do. And all those effects will for sure influence on how we organize mobility in the future. And there will be always issues with shortages, or that we get disruption because of incidents or natural accidents, whatever. We will have to analyze for all those supply chain risks and have to mitigate the impacts, diversify supply. All that must happen, and we must become resilient to any disruption which can happen. And global collaboration, I believe, is the key. We should really find back to that collaborative mindset in the world. That would be my recommendation and my dream that we can do.
Thank you, Frank. Okay. Yeah, I think supply chain, including the chip, still the big issue for the industry for a while after the 2 years, still after the 2 year of COVID-19. Yeah, but global collaboration should be one key answer to that. Yeah, I got another question from anonymous audience asking that do you think car software system will be dominated by one or two platforms, similar to what happened in smartphone industry? Is it interesting? Yeah. So we have BlackBerry, Android, iOS, a lot of Nokia, but nowadays the champion is one or two company. So what is your idea, the thoughts about the platforms, including the operating system for vehicle?
I mean, that's a really interesting question, and I guess a lot of answers there. What I currently recognize, the race is on. 80% of the OEMs are using, let's say, platforms stacks. You mentioned some of them, because if you run your own system and 20% or less are trying to build the whole ecosystem by their own. But it needs a lot of time, a lot of expertise, a lot of money to build it by your own. I guess at the end, but this is my personal meaning, my personal opinion, I'm expecting at the end to find collaborations at all of the companies, whether they use a stack or just to collaborate with software tech companies. At the end, I would say, like always, let's wait for 3 years, and the customers will decide which one they wanna buy, which one they love, they like, and they are willing to buy. At the end, currently, I do see many activities. At the end, in 3 years, in 5 years from now, I'm also guessing we will see only 2 or 3 big ones.
I have a similar opinion. I also believe that there will be a concentration process because everything is cost driven. And at the end, the OEMs or any vendor has to decide what is really his differentiating offering to the market. And the platform likely isn't it. It is the user experience. And that is what really differentiates the product offering of any customer from the other, any vendor from the other vendor. And here they will decide where they can differentiate, and that's even not the platform. And I also see that there will be, in, I don't know, maybe a proto standard or something like that. It's not defined, but it's establishing some standard which will be used by most of the vendors at the end. It's also my belief. It's somehow a law in how economics work.
Thank you, Frank. Okay, I still have a lot of questions coming, but some of the common question is regarding the price of the EV or even with the hybrid. It's still high. It's still new to the majority of audience here who are mainly from Vietnam. So the question is how when the EV the price will be kind of affordable for the consumer. I don't know. I don't have this question, but I believe that the battery is one big thing. Dung, you come from VinFast, so do you have any idea answer to this?
Yes, again, is my former company, so I just sharing my personal perspective, right? Not from VinFast, but like from my personal experience, on the new technology when they came out with the high price. It's like smartphone, even the clothes when it first come out, so with the high price. But along with the time, when the technology will become more affordable and it will reduce the cost of the technology. Second one, right? I think as we did mention before, there is more and more technology allow us to design a more efficient system. So with the more efficient system, the cost will go down. And when more and more OEM, more and more automaker join in the game, right? So they will gain experience by the vehicle development, and more common part will be shared, and the cost will go down. But I do believe that in the near future, the cost of the electric vehicle, will become very affordable for all of us, because in the very near future it will happen.
So I fully agree. Like in each and every industrialization process, it's all about scalability. It's all about, I mean, the robustness and the volume. And if the volume is there for a longer period of time, definitely I'm expecting the cost will go down to the same price like we can see currently in the combustion engine cars. The cost driver still is the battery. Already in the battery, I see in each and every generation the cost comes down, functionality, the range goes up. So therefore, hopefully, and that must be clearly the target, we should achieve the same price and cost level compared with combustion engines.
Yeah, I do remember by heart, for example, as Sigi did mention, the price of the battery. But if I'm not wrong, right, for the last 5 years or 7 years, the price of the battery cell reduced about 1.5 times. Maybe I'm wrong, but it's a big reduction since 5 years ago. So, and it will continue to reduce the cost.
There might also be other aspects which may support that the cost becomes smaller. If you think about how electrical cars are shaped at the moment, they look like cars with combustion engines. They don't really utilize or provide the advantages an electrical powertrain support, that we can shape the car much differently, much use or customer friendly. Why we need such a long hood, for instance, up front? For sure, maybe for mechanical protection in case of an accident, maybe. But nevertheless, I believe engineers will find much different shapes of a car in the future. Maybe there's less material to be built, and that even those structures will change, and we will therefore reduce costs. And on the other hand, if you think that becomes too cheap, what would happen then? That everybody would drive a car. It would be also chaotic.
Right. So I look like I have we have some audience joining this session. So let Mr. Wei is trying to ask a question. Go ahead, Wei, Mr. Wei.
Yeah, thank you, Mr. Kim. Hello, panelists. So I have a question about digital twins. I had a team who they are currently R&D about VR and AR technologies. So we also care about digital twins. So we believe in the future digital twin have many applications in many industries. But when we're thinking about the automotive industries, we feel we feel hardly to find the use case for specific scenario in automotive. So you here are very experienced in automotive industries. So please, can you suggest us use case, a realistic use case that's applied digital twins technology in automotive industries?
So I could give you now a list of more than 100 use cases, perhaps not appropriate to discuss this, but feel free to give me a call afterwards, or I mean, get in touch with me and we could discuss in detail all my use cases. And it's true for engineering, R&D, for production, for sales, for after sales, for retail, for, I mean, use cases during the life cycle. I'm always asking, what is the added value? And every use case should be and should provide a benefit in cost, in efficiency, in quality, maturity, and it goes along with the VR, AR. Also there, I'm an expert, spent there 30 years of use cases. So let's discuss this afterwards, yeah?
Thank you so much. Another, I want to ask about the following question. Could we combine the digital twins with the AR and VR for automotive? How do you think about this?
Yeah, so from my perspective, it's a combination. So with the digital twin, you have access to all kind of data. With virtual reality, augmented reality, which is the starting point for metaverse, we have still two problems. One is the data preparation. Still, we need too much time for the data preparation. So therefore, from my perspective, just to push the button must shift the whole data from the PDM, from the extended PDM system, representing the geometry, the shape, the material information, the production information, every details to be very, very fast with no or very, very less data preparation for VR and AR. Also, there I could discuss with you, I mean, hours and hours. Feel free to contact me.
Yeah, so last question I want to ask Mr. Kim. Yeah, sorry, because I'm very eager to have a question with on you here. So the last question I want to ask Mr. Kim. I know you are the head and the leader of the automotive industry in embedded software. So currently, do we have any plan to promote for the AR, VR, and digital twins technology in our embedded software to supply the service of the technology for our customer?
Okay, thank you very much for the great question. So I think we believe we are running out of time. So to answer the question of where on also Mr. Ngodak Viet is asking me. The question is the autonomous driving EV are the trends. So ECUs, hardware and software development are very important. So the question is how do you see Vietnamese or Vietnam can grow into this direction? And number two, how FPT can shape the future by joining into this area and having an technology ownership. For example, ECU of vehicle control unit for EV. Okay, organizer, can you help me to go to the next slide? Yes, so to answer very and weird question, let me share what we are doing, what we mean FPT software and myself doing in this automotive. So this is a list of the our current customer. You can see here we are working, providing the technology services, software services, and sometimes software itself to chip makers like NXP, Silicon Labs, Renesas, Microchip, etc. And by mastering the low layer software like micro device driver, hardware abstraction layer, we go to the middleware. That's why we are working with tier one supplier like Continental, Bosch, Denso, Aisin, etc. And we also move up the software layers to OEM, software component. So that's why we are working with Toyota, Volvo, Subaru, etc. And not only software, we are helping them to design and to simulate, analyzing CAD, CAE for the car, for the parts, assembly parts for the vehicle, like the door, the bumper, everything. And of course, for the digital twin or the AR, VR, I call it element technologies. So yes, the answer to Wei is yes, because the new way of the OEM, they need a new way, new kind of marketing, new kind of selling the cars. So and COVID-19 even accelerate that trend. When people they don't go to the car dealer, they can experience the car in the very virtual environment. So they can feel like they are in the real vehicle. So AR VR definitely is the very important technology for that, or for the car maintenance. You just hear from Sigi that there are more than 100 use cases. So not only for the car development, but also for the car marketing, sales, services. So we have a team in FPT software striving for AR, VR technology. And to extend that, we are working in the metaverse space also. To answer Viet's question, yes, we already, as you can see here, FPT software is working from the very engineering hardware area like a microcontroller, chip, design and verification to the software running inside the chip, to the basic software for the important software like AutoSAR, like Ethernet, USB, CAN, LAN stack, to the application like ADAS, AD, autonomous driving, and even to the outside of the car, mobility as a service. So we work vertically integrate from the chip to the cloud. So yes, there are many opportunity for Vietnamese engineer for of course, including FPT, because it's a science, it's a software, so we can do. And in this digital world, we don't need to go physically to some country. We can work from Vietnam, thanks to the advance of virtual environment, of cloud, of connectivity, of digital. And this is number two, how FPT can shape the future by joining this area. Yeah, we are, our majority of business now is providing the engineering services. I mean, we help the customer to develop, to design the software, and we implement it for them. We also help them to do the design and analyzing of the mechanical, and we help them to design and review or test the some circuit board like the onboard charger for the EV, so DC-DC converter, or some battery management system. Yeah, and combining our technology and experience, we for these two years we already have some end-to-end solution. It means that the customer that ask, hey King, can you help me to develop a body control module ECU? Yeah, I say yes. Okay. What's the requirement? Okay. So yeah, we can after that we can provide a full stack from the requirement definition to the system test, and as a kind of turnkey solution to the customer. Yeah, I think it's an interesting area, but still, FPT software and FPT believe that the service is very strategic and flexible and the right way for us to go. And the end-to-end solution is kind of extended services. We don't have strong direction policy to be hardware manufacturers. Okay, can you go next, please, organizer? So this is some feedback from our customer about Vietnamese engineer about FPT. You can see here we are doing well. Vietnamese engineer is doing great in not only software but also hardware and some even security space. So we have very good feedback from Ford Motor, from Frank, from some supplier, from OEM like Honda, like from Japan, like Hyundai from Korea. Yeah, so it's a very bright future for Vietnamese engineer, for young generation of Vietnam, including FPT, to go to this industry. There are a lot of opportunity, not only software, but also mechanical, also electrical. Yeah, it's time. It's already time. I think very exciting discussion and sharing, and we got a lot of questions. But unfortunately, we could not answer all the questions. And let us take the homework to answer the question by other means, like text or some answer through the fan page or other ways. I would like to thank you all the panelists here for joining this discussion from multiple time zones. Frank in Hanoi, Dũng in Hanoi, Sigi in Germany, and myself is in USA. I hope that we answer and share some already provide the audience with some insightful information. And I would love to ask each panelist here about some key takeaways from this discussion. Feel free to go ahead, Frank, Sigi, Dr. Dũng.
Yeah, so allow me to share first. Okay, thank you guys. So the takeaway, like electric vehicle is very interesting journey, I think, an interesting future. So let's together join the track, okay, and make it happen very quick. Thank you.
Okay. Yes, I saw that there's quite big interest technologies which are developed or maintained in Vietnam, and I'm really happy if you can attract engineers for our ODC at FPT, but also for NXP Vietnam. And that is for sure one of the purposes that we really communicate about what we are doing here, and that is really exciting and future-proof. And that would be great if you could get in contact.
Thank you, Frank.
Thanks.
Yeah, like always, start with the why. Why we are doing, and it's always starting with the value creation. At the end, we have to convince the customer to buy the new technology. So it's customer orientation, it's value generation, and what I love most is speed. So therefore, currently there is a huge change. I call it game changing. So be part of this game changing. Focus, strengthening your strength, and focus on the new North Star. Thank you for your huge interest, and was really nice to spend this hour with you guys. Enjoy the rest of the week.
Okay, so organizer, go to the last slide. I think we are already finished with the agenda. Next, please. Okay, so yeah, so what's next? So in FPT software, there are 5,500 engineers working in this automotive industry, including EV technologies. So, but we still need more college, more members, more friends to come to try for this very interesting areas. So yeah, if you are looking for a position, feel free to apply in FPT software website or contact our officer. We are looking for a mechanical engineer, electrical engineer, and software engineer. Or if you are still studying, you are a student, but you are going to look for a job, for work, you can go to FPT software. Come to FPT software for internship. We have offices in Hanoi, in Da Nang, Quy Nhơn, Cần Thơ, Ho Chi Minh City, everywhere. So yeah, feel free to contact us. So thank you everyone.
Okay, bye.
Thank you.
Yeah, I have I see Mr. Thức Nguyễn from SAP. Do you want to add some words in here? Sorry for not noticing you.
Great, thank you very much for allowing me to join the panel. But actually, I really enjoyed the conversation and the discussions this morning. So looking forward to learn more from all of you in the future. So thank you very much for sharing your experience and your knowledge.
Thank you. Yes.
Thanks
so have a great weekend ahead, everyone. Goodbye.
Thank you. Enjoy your weekend. Yeah, bye-bye.
Bye-bye.
Thank you.
Bye-bye.
Have a nice weekend. Bye-bye.
Con esa de Instagram se antoja ponerse naughty. En la playa bien drunk, ven vamos a hacer una story. Yo no te quiero para un ratito. Contigo yo no sé querer poquito.